All right, so but number 4 in this one.
Are those conjugates on the left side?
Oh, they are. They are conjugates of each other. Okay, do you want to work the left or the right side?
They're both hard.
Yeah, it's kind of like pick your poison on this one, right? Neither one looks really super easy, so let's just pick one.
Is this the one where you have to do both sides?
This is the one, yeah, I did.
Okay, that's it.
Yeah. All right, so I heard the left side. How do we add fractions?
Cross multiply.
Well, yeah, I know what you're talking about now. All right, so we're going to multiply each fraction by the other one's denominator, aren't we? Or you could just multiply them by both denominators and then make sure you put it over what you're multiplying by. All right, so we're going to multiply this first one by 1 plus sine of x on top and bottom, okay? And this one by 1 minus sine of x on top and bottom. So we get 1 plus sine of x times 1 over 1 plus sine of x times 1 minus sine of x minus, and then the second one I've got 1 times 1 minus sine of x over 1 plus sine of x times 1 minus sine of x. And all I did was actually just write it out with the multiplication, okay? I didn't actually do any other math work to it.
Would they just cancel out?
No, you don't want to cancel, because you cancel, you go backwards. You'll end up where you started, okay?
Okay. Yeah.
But now we've got a common denominator, don't we? So let's combine our numerators over that common denominator. So I've got 1. Y'all want to go ahead and distribute while we're doing that?
Yeah.
So I got 1 plus sine of x. Now be careful, because remember, this is a negative 1 then, okay? So minus 1 plus sine of x. And it's all over 1 plus sine of x times 1 minus sine of x. All right, what can we do now?
Something with the conjugates. I don't know.
Okay, so you're saying multiply the bottom out?
Yeah.
Okay, I think that'd be a good idea. Because I know, well, no, I don't. I know that if they multiply, we had said that they're going to give us a Pythagorean identity, right? When we multiply conjugates. So we've got that. What is the numerator? Can we do anything up here? It doesn't make it 0. My 1's will cancel, 1 minus 1. But I have sine plus sine, which is, yeah, because you distributed a minus 1. A negative 1 up there, right? Because it was being subtracted.
Wait, where are you at? Oh.
So that gives me what? 2 sine of x over, and you said you want to go ahead and multiply these? So that's his FOIL. So what's 1 times 1?
No. 1.
And then 1 times the negative sign? And then sine of x times 1? And then sine of x times negative sine of x.
Negative sin x.
Good.
And
Good.
then sin x is just cancel out.
No, you can't cancel. Oh, yeah. I see what you're saying. Sorry. I was thinking the wrong thing. All right, so she said when we combine like terms here, these do cancel. So we have 2 sine of x on top over 1 minus sine squared on bottom.
Wait.
1 minus sine squared. That sounds like a Pythagorean identity possibly, right? So we know, remember that sine squared plus cosine squared equals 1, right? So let's see what happens when we get sine and cosine on the same side. I meant sine and 1 on the same side. So let's move this over. So cosine squared of x equals 1 minus sine squared of x. Is this exactly the same as what we have in our problem?
Yeah.
So I can rewrite that then. This part here I can replace with cosine squared of x. So I got 2 sine of x over cosine squared of x. Guys, this is getting smaller, isn't it? It's getting really small. And we could keep going, but look at my other side. Yeah, right? So this is the one that after I worked it a while, I'm like, I don't think I'm going to be able to expand this side to make it look like the other. So let's see if we can take the other side and start bringing it down and see if we overlap somewhere here in what we've got in our work, okay? But every step I do on this other side, because I am not a big fan of working to both sides, so every step I'm going to check and see, do I have that written down already on the other side? If so, then I've got it proven. If not, I take another step. All right, so let's go look at the other side. What can I do on this other side?
Turn the reciprocals into sine and cosine and tangent too. I don't know.
We could, but I also see squares and ones, don't I?
Yes.
Yeah, I was thinking, nope.
Yeah, so I'm thinking maybe I can do something with that. So, look here. What about this? I'm not saying this is going to work, because it's not. Okay? But I just want you to see what happens. If I put secant squared plus 1, let's see, we've got that identity that says 1 plus tangent squared.
But we can move the one over.
Right, that's what I was about to say. When I move this 1 over, it has to be a minus 1, and it's not, is it?
But you can move the one around.
So I can't use that one. So that doesn't work. And I'm just going to have to get rid of my circle. I've got to backtrack all of this, okay? So, yeah, that scared me too. All right, so that didn't work. So let's try something else.
You can move the one over.
Can you do tan?
Okay, could I do tangents? You mean tangent squared plus 1?
Yes.
Yeah, I can. What is tangent squared plus 1?
Secant.
That's one of those identities, right? We know that 1 plus tangent squared, whoops, equals secant squared. So I know then I have secant squared of x plus secant squared of x over cosecant squared of x.
So then you can do 2.
Okay, yeah, add those together. So that's 2 secant squared of x over cosecant squared of x. That's good. We need a 2, don't we? Look at the bottom on my left side. I have a 2 in it, don't I?
Yeah,
Woo! We're getting there. Put that up.
the bottom is just cosecant of x, not squared.
Ah, thank you. Thank you. Good catch. That square is not there. That's some. Thank you. That would have messed me up big time, huh? All right. Now what? I don't have that. So far, I'm not repeating myself yet, am I? But I see everything else I turned on the left side into sine and cosines, isn't it? So can I turn secant and cosecant into sine and cosine?
Yeah.
All right. What is secant squared?
Wait, what?
If we're going to take everything to sine and cosine, I keep my 2.
1 over cosine.
Secant squared would become 1 over cosine squared. Over, what's cosecant?
1 over sine.
All right.
Squared?
No, it wasn't squared. That was my mistake earlier.
No, never mind. I was on the top one.
Yeah, wait. No.
Well, we got little fractions in there we don't like, do we? So either keep it, change it, flip it, or multiply by the little denominators.
So keep it, change it, flip it.
You like keep it, change it, flip it better, y'all think?
Could I see it right?
Okay. You can see it right now. All right. So when I multiply these two, this is the same thing as if I put the 2 up there, isn't it? 2 times 1. So this is 2 over cosine squared. Well, change it to multiply, flip it. So this is sine over 1. And so when I do that, we get 2 sine of x over cosine squared of x.
And I thought,
And that's what we had on the other side, isn't it? So because I ran into something that I already had over here, I've proven that they're equal. Now we could have kept going. We could have split the cosine squared up. We would have ended up with a tangent in it and simplified it even more. But we found 2 things that were equal while working out both sides. So we know that the beginning was equal as well. So we proved it.